Okay, guys, 1.3, first video. I just want to look at a few of these. These are models and applications, so I want to look at a few of these word problems. The first one I'm going to look at here is number 8 in the book, okay? So number 8, that's a little hard to read. I'll let you read number 8. I guess I'll read it. It talks about a new car that's worth $45,000 is depreciating in value by $5,000 per year. So essentially for number 8, the situation is you have a car, it's worth $45,000, and each year it depreciates or it loses $5,000 in value, okay? So this is something that's linear. Part A says write a formula that models the car's value Y, okay? So the car's value Y in dollars after X years. Well, 45,000, okay, minus 5,000x. This is kind of like, almost like a y equals, except for my m would be negative 5,000, x plus 45,000 would be my b value. I just wrote them in a different order. But you can see if you plug in x equal to 0, this term goes away, and when it's 0 years old, we know it's worth $45,000. When x is 1, we subtract off 5,000. That's the depreciation by $5,000 each year. So that's your answer to part A. Part B says to use this formula to determine after how many years the car's value will be 10,000. Okay? Well, essentially what they're telling us is when will y equal 10,000? Well, let's plug 10,000 in for y and see what x is. X is the when, right? They gave us the y, they want to know the x. So if I do that, I have 10,000, that's going to be the value of the car. I plug that right in for my y, is equal to 45,000, the original price, minus 5,000 times x, where x is the years since you bought it. Now we can figure that out. So we're just solving this for x just like in the last section, okay? So I'll go through, I'll start by subtracting 45,000 from both sides, okay? And what I'm seeing is I'm getting negative 35,000 equals negative 5,000 x, okay? I can go through, I can divide both sides by negative 5,000 to get x by itself. And finally, I'm seeing x is equal to, it's going to be 7. Well, what does a 7 represent? That's 7 years. So in 7 years, if it follows this model, the car is only worth about $10,000. Okay? Part C just asks us to graph this. Okay? Graph the formula in the first quadrant of a rectangular coordinate system. Okay? So then show your solutions to part B on the graph. So I can show them. So the first quadrant, we're mainly working right here in quadrant 1. So here's x, here's y. And here are the various years, 3, 4, 5, 6, 7. So x is in years. I see this is 7, okay? I'm going to say this is 45. So this is thousands, okay? This is the value of the car in thousands, okay? And initially, at 0 years, it's 45,000, okay? I guess this would be about 35,000, 25, 15, and 5. It goes down 5,000 each year. So after 2 years, it's gone down 10,000. 4 years, it's gone down 20,000. 6 years, it's gone down 30,000. And then finally 35,000. And that's right here. Okay, guys. That's the first video.